Hello students, in this video we are going to analyze the first 6 MCQs from the sample paper 2024 and 25. The first one is a uniform electric field pointing in the positive x direction exists in a region. Let A be the origin, B be the point on the x-axis at x is equal to plus 1 centimeter, and C be the point on the y-axis at y is equal to plus 1 centimeter. Then the potential at points A, B and C satisfy. The situation is like this. It is x, y plane and electric field is in the same direction of x-axis, that is uniform, and point A is at origin of the xy plane. Point B is at a plus 1 distance on the x-axis. Point C is at plus 1 centimeter on y-axis. Now here the potential at A is equal to potential at C. Why? Means these two are not along the direction of V, perpendicular to the direction of the E. And this value will be greater with compared to potential at point B. The reason is V decreases in the direction of electric field. So the potential at B will be smaller with compared to A. So according to the options given, VB will be smaller with compared to VC and VA. So option B is the correct option. Question number 2. A conducting wire connects two charged conducting spheres such that they attain equilibrium with respect to each other. The distance of separation between the two spheres is very large as compared to either their radii. The ratio of the magnitude of the electric fields at the surfaces of the two spheres. So these two conducting spheres, they are charged. Assume that it is sphere 1 and suppose say it is sphere 2. Both are connected by a conducting wire. Then the charge will transfer from one sphere to another sphere through the conductor until both potentials are same. That is V1 is equal to V2. Potential on 1, potential on 2, both will be equal. According to the formula, suppose say initially the charge on 1 is Q1, charge on 2 is suppose say Q2, K Q1 by its radius suppose say R1, its radius is suppose say R2. K Q1 by R1 is equal to K Q2 by R2. From this we can write Q1 by Q2 is equal to R1 by R2. That means the charges are directly proportional to their radii. Now what we need to find out? The ratio of electric fields. So E1 divided by E2 is equal to, we have K Q1 divided by R1 square divided by K Q2 divided by R2 square. K will be get cancelled. It will be Q1 by Q2 into R2 square divided by R1 square. That is equal to Q1 by Q2 is nothing but R1 by R2. It is R2 square divided by R1 square. So this value will be R2 divided by R1. Therefore, E1 divided by E2 is equal to R2 divided by R1. That means electric field is inversely proportional to the radius. So according to this, our option is B. Question number 3. A long straight wire of circular cross section of radius A carries a steady current I. The current is uniformly distributed across its cross section. Current is uniformly distributed. the ratio of magnitudes of the magnetic field at a point A by 2 above the surface of the wire to that of a point A by 2 below the surface. We can imagine this is a conductor and this is axis of the conductor or wire, and its radius is given as A. Now we need to find out the ratio of the magnetic fields A by 2 above the surface. From the surface, a distance A by 2 means this is nothing but A. This is the distance, or R is equal to A plus A by 2. Here assume that the strength of the magnetic field is B1. Now below there are point A by 2 below its surface. Below its surface means somewhere here. This is A by 2, and from the axis also this one will be A by 2. We need to find out the magnetic field here. Suppose it is B2. Finally, we need to calculate the ratio of B1, the ratio of magnitudes of the magnetic field at the point A by 2 above the surface and below the surface. So while coming to B1, B1 is equal to mu naught I divided by 2 pi r. That is mu naught I divided by 2 pi into small r is nothing but here A plus A by 2. That is equal to mu naught I divided by 3 pi A, will get it. And B2 is equal to mu naught I R divided by 2 pi into A square. This is the formula for magnetic field inside the conductor at distance R from the axis. So mu naught I, here R is acting as like A by 2 divided by 2 pi A square. This value will give us mu naught I divided by 4 pi A. Therefore, B1 divided by B2 is equal to mu naught I by pi A will be get cancelled. We will get 4 by 3. The option is C. This problem is similar to one of the NCERT problem solved example from moving charges and magnetism and application of Ampere's circuit law. The diffraction effect can be observed sound only, light waves only, ultrasonic waves only, sound waves as well as light waves. So diffraction effect can be observed in both sound as well as light waves. Fifth one. A capacitor consists of two parallel plates with an area of the cross section of 0.001 meter square, separated by a distance of 0.0001 meter. If the voltage across the plates varies at the rate of 10 power 8 volt per second, then the value of displacement current is. Here we need to find out displacement current. The given data here is area is equal to 0.001 meter square. That is nothing but 10 power minus 3 meter square. And the separation between the plates is 0.0001 meter. That is 1 into 10 power minus 4 meter. And dV by dt is nothing but 10 power 8 volt per second. Displacement current is equal to epsilon naught d phi by dt. It is rate of change of electric flux times of epsilon naught. That is epsilon naught into d by dt of electric flux is nothing but EA, we can take it, that is equal to epsilon naught A into dE by dt. We can write it is epsilon naught A, E can be written as V by D, so dV by dt also we can write. Now if you substitute all the values, epsilon naught is nothing but 8.854 into 10 power minus 12, A is 10 power minus 3, divided by D value is nothing but 10 power minus 4, dV by dt is 10 power 8. This value will be 8.854 into 10 power minus 3 ampere, we will get it. So the option is 8.85 into 10 power minus 3 ampere. Now, in series LCR circuit, the voltage across the resistance, capacitance and inductance is 10 volt each. If the capacitance is short circuited, then the voltage across the inductance will be. Here he has given the potential drop across resistance, across capacitor, across inductor is 10. We can write it is IR is equal to IXC is equal to IXL, that is nothing but 10. From this we can write R is equal to XC is equal to XL is equal to 10 ohm. Now whenever the capacitor is short circuited, means we can ignore the capacitor, then Z value will be square root of R square plus XL square, that is 10 square plus 10 square square root of, that is 10 root 2 ohm. Now the potential or the voltage across the inductance whenever capacitance is short circuited is equal to some current into XL. So this I is nothing but V divided by Z into XL value is nothing but 10. V is also 10, it is nothing but 10 root 2 into 10. That is nothing but 10 by root 2, otherwise we can write it is 5 root 2 also whole. So here 10 by root 2 is given, so option C, 10 by root 2 volt across the inductor when capacitance is short circuited or capacitor is short circuited. Thank you. The rest of the questions I will upload soon with the detailed answers. Please subscribe and follow the channel. It will be helpful for you for coming the board examination. Thank you.